Your next reading is Probability Concepts, Overview. These are all learning outcome statements in this reading, and we will briefly cover all these one by one. Starting first with define a random variable, an outcome, an event, mutually exclusive events, and exhaustive events. Take an example of a dice. When we say a random variable, it means any uncertain quantity or number. For example, if I roll this dice, if 1 comes, it could come 2, maybe 5, 6. So a random variable is an uncertain quantity. In the given context, it could be any number from 1 to 6. Outcome. Outcome is an observed value. In this case, anything between 1 to 6 would be an outcome. So outcome is an observed value of a random variable. What is an event? Event is the activity. Event is the rolling of the dice and the turning up of a certain number. That number is outcome, but the activity of rolling the dice is called event. What is mutually exclusive events? Mutually exclusive events cannot happen simultaneously. Either you will have 1 on the dice, or 2, or 3, or 5, or 6. 1 and 2 cannot occur simultaneously unless you have 2 dice, right? So mutually exclusive events are events that cannot happen at the same time. They cannot happen simultaneously. And finally, exhaustive events. Exhaustive events means those that include all possible outcomes. How many possible outcomes are there when we roll a dice? 6. Either 1 or 2 or 3 or 4 or 5 or 6. So combination of all these outcomes combined will give you a term called exhaustive events. So just these terms you need to know. Then we have state the 2 defining properties of probability and distinguish among empirical, subjective, and priori probabilities. The 2 defining properties are the probability of occurrence of any event is between 0 and 1. Either the event will not happen, or if it does happen, it is certain to happen, it will be 1. Probability will fall anywhere between 0 and 1. It cannot be less than 1, means it cannot be less than 0, means it cannot be negative, and it cannot be more than 1. It cannot be more than 100%. So your probability of any event will fall between 0 and 1. This is the first defining property. The second one, if a set of events E1, rolling 1, rolling 2, 3, 4, 5, 6, all these are mutually exclusive and exhaustive. If a set of events 1, 2, 3, 4, 5, 6, in our example, they are all mutually exclusive, they are all exhaustive, the probabilities of those events getting a 1 or 2 or 3 or 4 or 5 or 6 will give you 1. Means getting a 1, 1 over 6. Getting a 2, 1 over 6. Getting a 3, 1 over 6. 4, 1 over 6. 5, 1 over 6. Adding all these will give you 1. That's what it means with the second property, that events, if they are mutually exclusive and exhaustive, their sum would be equal to 1. Then these 3 terms, empirical probability, subjective, and priori. When we say empirical probability means the probability that is based by analysis of past data. It is based upon historical facts or historical data, and we draw conclusion based, or we draw probabilities from the past data. It requires no judgment. Of course, it is based upon numbers, past facts, past data. So we use historical non-random data in order to generate empirical probability. Opposite to this is priori probability. Priori probability based on logical analysis. It is determined using reasoning, formal reasoning, inspection process based upon logical analysis. And then we have subjective probability. It's an informal guess, a personal judgment. Maybe I say this student has 50% probability of getting through the CFA level 1 exam. I'm using my experience, his class attendances, his response rate. So I just give an idea that he will 50% probability he will get through. So subjective probability is an informal guess where an analyst or an individual uses his experience, his expertise, about certain domain, and then he gives his judgment. So when we say objective probability, empirical and priori both are objective because they are based upon facts, data. This is the one that is based upon guess, pure guess. All right, next learning outcome statement. State the probability of an event in terms of odds, odds for, and odds against the event. Probability in terms of odds. When we say odds, we can state probability in terms of odds. Stating the odds that an event will or will not occur, it is an alternative way of expressing a probability. For example, let's say I have a bag. It contains 4 red balls or 4 green balls, let's say, and it contains 6 red balls. There are 4 green balls and there are 6 red balls. If I draw a green ball at random, I win, and I then replace it. So what is the probability of drawing a green ball? It is 4 out of 10. This is the normal way of writing probability. But writing or stating the probability in an odds way, or what you call the writing event, that whether a certain event will occur or not, this is a specific way, an alternative way of expressing probability. I can write it this way as well. Probability of occurrence divided by probability of non-occurrence. How many events are in my favor? 4. How many events are against me? 6. Probability of occurrence versus probability of non-occurrence. That is called the probability odds for, right? So if you simplify, it is 2 to 3. We can do it in totally reverse order. That is odds against. Now, if you do it in totally reverse order, there are 6 events that go against me, opposite to 4 that go in my favor. So it's going to be 3 to 2. So this is what you call the odds for an event, and this is the odd against the event. So it's not something very technical. You can just use your intuition to get the numbers and get it done. Next, distinguish between unconditional and conditional probabilities. When we say conditional probability is the one where the occurrence of one event affects the probability of the occurrence of another event. For example, if I have, taking the same example, if I have 4 green balls, 6 red balls, if I draw 1 green ball, the probability of drawing a green ball is 6 upon 10, and I do not replace it. What is the probability of getting another green? Now, getting another green will be 3 out of 9. See, this probability is dependent upon the previous probability. So conditional probability is the one where occurrence of one event, this one, affects the probability of the second ball, whether the ball is green or it's red. So conditional probability is the one where occurrence of one event affects the probability of another event. And when you say unconditional probability, it's quite self-explanatory, also called or also known as marginal probability. It refers to the probability of an event regardless of the past or future occurrence of other events. For example, taking this simple example, we have 4 green balls and 6 red balls. Drawing a green ball out of the total bag, 4 out of 10, that is simple 2 by 5. If I replace the ball again, and then again I try to calculate the probability of drawing a red ball, it's 6 upon 10. So this probability is not dependent upon what the previous probability was, because the ball was replaced. It's an unconditional probability. So take an example here. The likelihood of an event occurring is defined as what? Remember, there is another way to use, we use likelihood to mean unconditional probability. Likelihood is a synonym term to unconditional probability. Just like in the previous example, drawing a green ball, provided green ball has already been drawn. So this is likelihood or conditional probability. An unconditional probability is most accurately described as the probability of an event independent of the outcomes of other events. Unconditional probability doesn't depend upon the past or future occurrence of other events. It's independent of others. So moving on to your next reading, explain the multiplication, addition and total probability rules. First, the multiplication rule of probability. Multiplication, we will discuss many examples and do many questions, and so everything inshallah will be discussed in detail. These concepts will be refined. The multiplication rule of probability is used to determine the joint probability of two events. Let's say we have an event A and event B. We want to calculate the joint probability of A and B. So probability of A intersects B, or A intersection B, or A or B combined, is equal to probability of A provided B or given B multiplied by the probability of B. Or we can write it this way: probability of A given B is equal to probability of A intersect B, this part, divided by the probability of B. This is called multiplication rule of probability. Just grasp the idea. We will apply this idea on actual questions. Just overview is required. We'll jump straight to the questions after that. Addition rule of probability. It is used to determine the probability that at least one of the two events will occur, either A or B. It is written this way: probability of A or B is equal to probability of A, that will include all of this, plus probability of B, that will include all this, but this common part is also included. In order to calculate the probability of A or B, we need to exclude this common part where A and B are intersecting. And this is represented by intersection, A intersection B or AB, right? So probability of A or B is equal to probability of A plus probability of B minus the common part between them where A, B intersect. This is called the addition rule of probability. If these events are mutually exclusive, say this part would be 0. It will be simply probability of A plus probability of B. Next, the total probability rule is used to determine the unconditional probability of an event given conditional probability. This is written this way, and we will, of course, getting the idea, we will apply this in lots of questions that we have planned to do today. Probability of event A is equal to probability A given B, B1, into probability of B1. This is the first leg of the tree. Probability of A given B2 into probability of B2, and so on till you get all the events under consideration. So B1, B2, and so on, these are the mutually exclusive and exhaustive sets of outcomes. So their result final will give you the unconditional probability of A. We will discuss this all in this example, and then of course we will apply this concept in the questions as well. This is your 6th LOS. Calculate and interpret the joint probability of two events. Now this is the example that will explain the idea, just the one we have discussed a little while ago. The joint probability of two events. Consider the following information. The probability of the monetary authority, the central bank in your country, increasing interest rates I is given as 40%. So probability of increase in interest rate is 40%. The probability of recession given an increase in interest rate, because when the interest rates are raised, the demand by businesses for funds decreases, resultantly the output, the demand by consumers falls, results in recession, less production. So the probability of recession given an increase in interest rate is 70%, given as PR given interest rate is equal to 0.7. What is the probability of R intersects I, R and I, the joint probability of recession and an increase in interest rates combined? So what we will do, same thing we just discussed a little while ago, probability of R intersects I is equal to probability of R given I multiplied by probability of interest rate increasing. So simply 0.7 times 0.4. So this is the probability of recession and interest rate joint. So that gives you 0.20 to be the correct option. Next, the probability that at least one of the two events will occur given the probability of each and joint probability of the two events. Using the information in our previous example, interest rate and recession example, and the fact that unconditional probability of recession PR is 34%. Assume numbers. I've taken this example from your textbook. Determine the probability that either interest rates will increase or recession will occur. That's what we discussed a little while earlier. So probability of recession or increase in interest rate is equal to probability of recession plus probability of interest rate and less the common part between them where R and I intersects. Probability of R intersects I, R and I. So we have this number given. This was already given, and deduct the common part. So this will give you the probability of recession or probability of interest combined. This is called when at least one of the two events will occur. Lastly, a joint probability of any number of independent events. Independent events means an event occurrence doesn't depend upon the occurrence of other events. So what is the probability of rolling 3 4s in one simultaneous toss of 3 dice. When you toss dice first, getting a 4, the probability is 1 over 6. We roll it again, getting a 4, probability is 1 upon 6. Getting a 4 again, 1 upon 6. Since the probability rolling a 4 is 1 over 6, so it's just repeating 3 times, so you'll just multiply these 3 probabilities to get 1 upon 216, and it's simply 0.00463. We're just getting the ideas. We'll apply all these ideas in a question. We don't want to spend more time on this because lots and lots of questions are there waiting for us. Distinguish between dependent and independent events, just discussed. Independent events refer to events for which the occurrence of one has no influence on the occurrence of another, just like 1 by 6 and 1 by 6 and 1 by 6. They were all independent events. A bag of marbles contains 3 white and 4 black marbles. A marble will be drawn from the bag randomly 3 times and put back into the bag. It means it's the probability with replacement relative to the outcomes of the first 2 draws. Since they have been replaced, the probability that the third marble drawn is white, since we are replacing the marbles and again and again, so these events are independent. Had it been without replacement, that would have been dependent. So that makes A to be the correct option. Next reading, next LOS is calculate and interpret the unconditional probability using the total probability rule. Here is an example to explain the idea, total probability rule. The event Y and Z are mutually exclusive and exhaustive. Probability of Y occurring is 0.4, 40%, and probability of Z occurring is 60%, 0.6. If the probability of X given Y is 0.9, probability of X given Y is 0.9, and at the same time probability of X given Z is equal to 0.1. What is the unconditional probability of X? Unconditional probability of X. We just discussed this a little while ago. Probability of X is equal to probability of X given Y multiplied by probability of Y plus probability of X given Z multiplied by probability of Z. Plug in the numbers and you should get your result. We have 0.4 times 0.9 plus 0.6 multiplied by 0.1. So their simplification will give you 0.42. This is the unconditional probability of event X occurring. Next, explain the use of conditional expectations in investment application. Conditional expectation. Expectation or expected value of a random variable basically is the weighted average of possible outcomes. These are the possible earnings. Probably weighted means this is the weights. Probabilities are being used as weights. 10% weight has been given to this earning, 40% weight to this. So if you just simply calculate their EV multiplying these probabilities with the individual earnings, it will give you the expected value of your earnings. A straightforward thing. We have done it many times in your elementary classes. Next, explain the use of tree diagram to represent an investment problem. Here we go, a good one. There is an 80% chance that the economy will be good next year. 80% chance that the economy would be good. And 20% chance that the economy will be bad. Just an overview, gentlemen. Do not expect more. Just an overview. We will rediscover these ideas through questions. That's my philosophy. 10% theory, 90% questions. And if you believe me, I would go straight 100% to questions. I believe in questions. Books bore me. Theory bore me. I love to do questions. It's all about questions. There is an 80% chance that economy will be good next year and 20% chance it will be bad. If the economy is good, there is 60% chance that XY's incorporated EPS will be $3 and 40% probability that it will be 2.5. And if the economy is bad, which is 20% probable, in that case, there is 70% probability that XYZ incorporated EPS will be $1.5. And there is 30% probability that their EPS will be $1. What we are required to do, what is the firm's expected EPS? We have constructed the decision tree. We just have to roll it back. How do we roll it back? We will take 60% of 3 plus 40% of 2.5. This brings us $2.8 of EPS, expected EPS, in case if the economy is good. 1.5 times 70% and 30% of 1 gives you 1.35. Now, if the economy is good, the expected value of EPS is 2.8. If it's bad, which is 20% probable, it's going to be 1.35. If you bring it back again, 2.8 is called rolling back the decision tree. 2.8 multiple 0.8 plus 1.35 times 0.20. It gives you a total EPS, expected EPS of 2.51. So this is the way of doing tree diagram solving. Just physically you lay down the working and then just simply roll it back and get what you need at the origin of the decision tree. So that gives you 2.51, that's B, and B is the correct option. Moving on, calculate and interpret covariance and correlation and interpret a scatter graph. What is covariance? Covariance is a measure how two assets move, whether they move in the same direction up or do they move in the opposite direction. It is used in constructing the portfolio to see how the assets move. So covariance is a measure of how two assets move together, and this is how we calculate covariance. We will do many questions involving covariance and correlation as well. So covariance will be calculated in our questions and examples as well. Then we have correlation. What is covariance? Covariance is a measure of how two assets in our portfolio move together. And correlation is in fact a derivation of covariance. To make the covariance of two random variables easier to understand or interpret, we can divide the standard deviation of individual variables, which we are considering two assets, asset A and asset B. So this is the standard deviation of asset A, standard deviation of asset B. So if we divide the covariance with standard deviation of these two assets, we will get a measure called the correlation coefficients. So it's a measure similar to the covariance one. The difference is that covariance can have a result of negative infinity to plus infinity. Covariance is unbounded. It can have very high value, very low value, but correlation is bounded by these values. Your coefficient of correlation will be greater than equal to -1 and less than equal to +1. So what is correlation? It's a measure, the direction. It measures the direction as well as the magnitude between the two variables, how good fit they are. Like for example, this is your scatter graph. We have plotted the returns of X and Y, and they are nicely moving upwards, showing a positive slope, indicating that as X increases, Y increases. So if you calculate their coefficient of correlation, so it will be close to 1, indicating they are perfectly positively correlated. If the R is exact +1, it means they are perfectly positively correlated. If the R's result is +1, it means they are perfectly positive. They move proportionally in the same direction. If they fall together. If they increase together. To the contrary, we may have certain returns that might be linked this way. If this is X returns and Y returns, and they are scattered this way. This is your scatter graph. Scatter graph or scatter plots are the method for displaying your various variables and how they are related along X and Y axis. So it's indicating that they are negatively correlated. If X increases, Y decreases, and when the X decreases, Y increases. If they are perfectly negatively correlated, the coefficient of correlation will be -1. And if they are perfectly positively correlated, it will be +1. R can fall anywhere between -1 and +1. Let's say if it's 0.88, it means a very strongly positively correlated. If it's -95, strongly negatively correlated. But close to +1 and -1 means they are strong. But if it's closer to 0, if R is equal to 0, close to 0, it means the relationship is either there is no relationship or the relationship is very weak. Having R equal to 0 means the variables are unrelated, like this. In this case, R would be 0. R would be 0. In this case, R will be very close to, had it been a straight line, a perfect straight line, it would have been +1. Since there is such certain deviation from the line, so it will be maybe 0.98 or 0.95, positive. So correlation, covariance, they help us measure the strength of two variables, how well they are connected, whether they are positively correlated or negatively correlated, and what is the extent of relationship, the strength of their relationship. That was your LOS 11. Next, calculate and interpret the expected value variance, standard deviation of random variables and returns on a portfolio. This we will discuss in detail in our questions. Let's say we have two portfolios, portfolio A and B, and this is the probability of returns from portfolio A, and this is the probability of returns from portfolio B. So when we say expected value, simply multiplying the probabilities with the returns of A will give us the expected value return on A, EXA, and we can do the same for portfolio B. Multiplying these probabilities with these returns will give you the expected return on portfolio B. Then if we have weighted portfolios, different assets, like for example we have two assets in our portfolio, A and B, and let's say take the specific example. We have two investments, some in stock, some in bonds. 30% has been invested in stock with standard deviation of 20%, and we have invested 70% in bond with standard deviation of 12%, right? We are required to calculate the variance of the portfolio. Now, this WA represents the weight of stock, that is 30%. WB represents the weightage given to bonds, and these individual standard deviations will be replaced with the variance sign. Simply you'll write here 0.30 squared, 0.70 or 70 whole square, plus weight B, that is 70, this was 20, sorry, 70 squared and 12 squared, and you will put all these. We will also be given the coefficient of variation between R and B. Plugging all these numbers will give you the variance, and interpreting the variance is what we are expected to do. The variance, if calculated to be negative, coefficient of variation, if calculated to be negative, it means the investments are negatively correlated, and a positive result will mean that they are positively correlated. We will do this through examples. Let us just skip through these and focus exactly where do we need to go. Calculate and interpret covariance given a joint probability function. We have been given two stocks, X and Y. These are their returns, 2, 6 and 10, 10, 2.5 and 0, and this is their probability. Calculate and interpret covariance given a joint probability function. So these are the returns with the probabilities given. The first step we should do is to calculate the mean, multiplying these probabilities with the returns. Then multiplying these probabilities with the returns will give you EX, EY, which in fact means the mean and mean Y, right? The next step will be to subtract these returns from the mean. 2 minus 6, 6 minus 6, and 10 minus 6. Here you will have 4, 10 minus 4, 2.5 minus 4, and 0 minus 4. In the last column, we will take this probability 0.3, 0.4, and 0.3 and multiply these two results here and sum up all. It will give you the covariance of X and Y, and it is negative 12. This negative 12 indicates that these two returns are negatively correlated. There is negative covariance between them. That was what we were required to do. Calculate and interpret covariance given a joint probability. The negative number indicates that they are negatively correlated. Next, we have Bayes' theorem. The basic idea behind Bayes' theorem is that we can flip from one conditional probability to another. Like for example, probability of A given B, we just discussed a little while earlier, is equal to probability of A, B together, which we call A intersect B, upon probability of B. This is just we discussed a little while earlier. What if we flip the probability? If we flip the conditional probability, the probability of B given A, it will be equal to again probability of B intersect A upon probability of A. Now, probability of A intersect B or probability of B intersect A, effectively they are the same. They are the same because intersection between A and B or B and A means the common probability both sides. So you can replace one with the another. So it means if we just rearrange the original equation and replace probability of B intersection A with this result, so what final result you will get? Probability of A given B Like for example, if you calculate this value, it's going to be probability of B intersects A is equal to probability B given A multiplied by probability of A. I'm going to replace this with this. So what I will get, probability of B given A multiplied by probability of A, and there was already probability B in the denominator. So this is your base theorem. It's very helpful. It is used to flip the conditional probability from one to another. Sometimes we have been given this, we can calculate this, and sometimes we are given this and we might be required to calculate. This is Bayes' theorem, and it is used to flip one conditional probability to another. There are many questions in the list of questions that we have selected for today, and we are just rushing through so as to jump to the question as quickly as possible. Your last LOS: identify the most appropriate method to solve a particular counting problem and solve counting problems using factorial combinations and permutations. First counting problem is multiplication. Now, there are five counting problems, and most of the students get confused. Where do we need to use which one? Let us discuss them one by one. Multiplication counting is used when there are two or more groups. For example, I have three numbers of choices of bread. I want to make sandwiches, by the way. This is what I want to make a sandwich. So I have three breads to select from. I have two number of choices of cheese. I have four number of choices of meat, chicken, beef, mutton, etc., or fish maybe. And I have three number of choices of sauce. Now, how many different sandwiches are possible? Since it is explicitly, this is clearly more than two or more groups. So in this case, we use multiplication. We are not drawing any selection. We're just simply making arrangement out of these four different options: three from bread, three options from bread, two from cheese, four from meat, and three sauces. So just multiplying these all four, 3 into 2 into 4 into 3 will give you possible 72 different sandwiches by interchanging these different ingredients. This is the situation where you use multiplication. Next, factorial. Factorial is used when there are no groupings as such. We just want to arrange things in a specific order. For example, you are asked to rank your 4 most favorite movies, A, B, C, D. How many different ways is there to rank these my top 4 favorite movies? A, B, C, D. Right? There is no grouping again. So it's simply going to be 4 factorial. Factorial is used when there are no groups. We are just arranging a given set of n items. There are 4 items. So simply arranging them will give you result. 4 factorial will give you 24. So this is where you use factorial. Next is labeling. Labeling is used when we have to draw 3 or more groups of predetermined size. For example, we have a set of 8 stocks. Given example in your book, we have set of 8 stocks, and we want to select certain groups of items. We want to select 3 stocks for long-term hold, 2 for short-term hold, and 1 just to sell. How do we arrange this? Total number of stocks 8 factorial. Out of this we need 3 that we want to hold, 2 that we want to short-term hold, and 1 to sell. Simplifying all this will give you the number of possible arrangements or number of possible labels, 280. Lastly, second last is permutation. Combination and permutation. Combination formula, I'm sure all of you know, is NCR. It applies only to 2 groups. This is the larger one, and you have to select something from the large group. Where order doesn't matter. You just need to look for the word choose or combination. For combination, there is no requirement of order. Order doesn't matter. Whether it's ABC or CBA or BAC, order doesn't matter. So let's say if this is the population of which you have to select, how many different, let's say you have a group of 15 students, and you want to make a committee of 4 students. Since the order doesn't matter whether ABC or CBA, so it is simply going to be 15C4. So combination formula is used when only 2 groups of predetermined size are made and where order doesn't matter. So solving 15C4 gives you 1365. There are 1365 ways of forming a committee of 4 students out of these 15. Last one is the permutation. Permutation is the arrangement where we make 2 groups, one from the larger one, where the order matters. You need to look for the word order. So permutation formula applies to only 2 groups of predetermined size. So you need to look specifically for order. For example, how many ways are there to sell 3 stocks out of 8? You have 8 stocks and you want to sell 3 out of them. If the order of the sale is important, which one you will sell first, which one you will sell second, which one you will sell third. Since the order matters and there are 2 groups, so we'll use permutation. It's going to be 8P3, and solution of this will give you 330. There are 336 ways of selling 3 stocks out of these 8. So that ends your reading probability concepts completely.